This video is following on from the work that you've done on the product rule, quotient rule and chain rule differentiation. There seemed to be some difficulty. It is difficult doing the simplifying afterwards, so I just wanted to put together a quick couple of examples looking at how the simplifying works. There's some typed writing up at the top here which I would recommend that you read at some stage. Basically what I'm saying here is that there aren't any hard and fast rules, generally speaking, because largely it depends on what you're going to do with something once you've differentiated it. But there are some guiding principles here which you should have a look at, and that's what I've typed up there, so I shall leave that there for you to read. I don't want to spend time thinking about how to do the differentiation, because generally speaking you seem to be pretty good at that. It's really about the simplifying, and so I wanted to go through a couple of examples, and here's a first example. This was the expression that I was thinking about differentiating. As I say, I'm not going to do the actual differentiation for show you how that works, so I'll just put in my result. So when I differentiated that expression, what I ended up with was this. I got dy by dx equals 8x times x cubed minus 6 to the power of 2/3. And then I got a second term, so there's my first term. Cubed on the x isn't very clear, but I hope to remember that. So my second term, leaving the first part undifferentiated for x squared, that now needs to get multiplied by 3x squared, because we used the chain rule on this part, and then a times 2/3 with the same bracket, x cubed minus 6 with the power reduced by 1 to minus 1/3. So there's my differentiation done. You can check through that for yourselves if you wish to. Just tidy it up a little bit because it's a bit messy. Still not great, but there we are. The point I'm making there really essentially is, look, a few of you at least notice that I'm being careful to write x's and multiplication signs differently in case I get them confused. So there's my differentiation done, and now it's about tidying up and factorizing. So notice that I'm thinking about this already as just from the start. I'm thinking about this as two terms, and very often you'll get two terms. In fact, pretty much always you'll get two terms when you've had to use the product rule. And when you use the quotient rule, you'll get two terms, but they'll be part of a fraction as well. So same kind of principle applies there. And this is where we need to do the difficult factorizing and tidying up, where we get these two terms appearing. So I'm thinking about those two terms, essentially the two things which are separated away by the plus in between them. The first term looks okay. I don't think I can do anything tidying up wise with that first term, but this is the first thing I would be thinking about. I'd just be looking at the two terms and thinking, well, do I need to tidy them up at all? Yes, I do need to tidy up the second term. I notice straight away that there's some cancelling out that will do the 2/3 here. The 3 on the bottom of that 2/3 and this 3 here will cancel each other out, won't they? So that's one stage that I'm not going to need to worry about as I go on to my next line, which goes like this. So the first term here can just get repeated exactly as it is. That's as tidy as it'll come. 8x brackets x cubed. Try and make that a bit clearer this time. Yeah, that's a bit better. X cubed minus 6 to the power of 2/3. That's all as it should be. Still having trouble with those threes. Second term is the one that needs tidying up. I've got a 4x squared times, and now that's just an x squared in the middle, and then that's just times to 2, and then the bracket at the end. I'll leave the bracket at the end as it is, but the other bits in front of the bracket can get tidied up into just an 8x to the power of 4, can't they? So 8x to the power of 4, and then the bracket. minus 6 to the power of minus a third. And so now I'm looking at these two terms and I'm noticing that there are things that they've got in common. So for example, both terms, I thought that was a highlighter. Both terms have got this 8, or they've got a number. It happens to be the same number in this case, and it won't always. Sorry, no, highlighting just trimmed a little bit further than it meant to. So we've got an 8 in both parts. We've also got here an x, and here we've got an x to the power of 4. So really what I'm identifying here is where the two terms have got things in common, that I can start to identify common factors in the two terms so that I can factorize them out of them. And then of course both terms have got the bracket, and the important thing about the bracket here is that it's got exactly the same stuff inside. It's got different powers on it. I've got 2/3 in this first term and minus a third in this second term over here, but the crucial thing is that they've both got the same expression inside the bracket, and which so that allows them to be treated as common factors. So there we are. I've identified all the separate parts of the two terms there. So now I'm ready to start doing some factorising. 8 is common to both, so 8 can come out of both terms. X I've got in the first term, and in the second term I've got x to the power of 4, so the common factor there coming out is x. And then they've both got this, as I say, they've both got the same bracket with different powers on them, but the same bracket. So that's going to appear out here as the as a common factor in both terms as well. Question is, what power should I put on it? So think about what we did with the x. We thought we've got x in the first term, x to the power of 4 in the second term. I should take outside the lowest power that has the lowest power of the common parts in the two terms. X to the power of 1, x to the power of 4. The lowest power there is 1, so I'm just going to take an x to the power of 1 or x out of it. Now I'm going to apply the same principle to the bracket as well. So what's the lowest power on the bracket? Well, the lowest power is minus a third. So that's the power that I'm going to put on this bracket as I factorize it outside the expression here. So there's my factors taken out. So now I've just got to think about what is left from each of the two terms in the line above, having extracted those factors. 8 has come out completely of the first term, so I don't need to worry about the numbers. X has come out completely. The bracket, I've taken a power of minus a third out there. So inside my square bracket now, I need to think, what would I multiply this bracket to the power of minus a third by to make it the same as the bracket to the power of 2/3 in the line above? Well, clearly, when I'm thinking about multiplying things with powers on them, I'm thinking about adding the powers. So what power would I need to add on to minus a third to make it 2/3? Well, that's just got to be 1, hasn't it? So that should be here. The part that's left over from that first term is going to be, x cubed minus 6 to the power of 1, and I just won't bother writing that power of 1. Now if I multiplied that bracket and this bracket with the power of minus a third on it together, would I get the same as this bracket up here with the power of 2/3? Yes, I would. So I'm happy that I've done my factorising correctly. So I'm moving on to my second term, the 8x to the power of 4x cubed minus 6 to the power of minus a third bit. Again, the 8 has come out totally, so I can ignore the numbers. X to the power of 4, I took an x out, so that's going to leave me with an x cubed, because when I multiply x cubed in this bracket by that x at the front, that's what gives me that x to the power of 4. And with the x cubed minus 6 part in its bracket here, I've taken all of that out. It's got the right power on it. It's got a minus a third out here, which is what it had there, so it doesn't need to appear in this term at all here. So that's the end of my factorising done. And now it's just a case of tidying that up. So I can tidy up the square bracket to leave everything else as it is. Now to the front here, and then that square bracket is an x cubed minus 6 plus an x cubed, so that's really just 2x cubed minus 6 There we go. What I notice about that final bracket that I've written there is that it's got a common factor of 2, so that can come out, and that 2 that comes out of this bracket can join in with the number part of the original factorising I did. So that's now going to make that a 16 at the front there. The x isn't going to change. The x cubed minus 6 isn't going to change, nor is its power of minus a third. And then all I've got left is that bracket with the factor of 2 taken out of it, so that's going to leave me with an x cubed minus 3. Sorry about that cubed, I might just try and tidy that because that's the last bit. So there's my final answer. 16x. Oh, not quite a final answer, beg its pardon. What I don't really like is the fact that I've got a negative power on this first bracket that I've appeared here. Don't really want to leave things with negative powers if I can avoid it, and I can avoid it by just dropping that down to the bottom of a fraction, putting it on a denominator instead of leaving it at the top there. So I'll leave my 16 and my x cubed minus 3. I'll leave all of that part on the top of a fraction, and then my x cubed minus 6 bit can go from the top with a power of minus a third, dropping down onto the bottom and making the power positive instead. So x cubed minus 6 to the power of a third, and not brilliantly written, sorry about the slightly untidy final answer there, but there's my final answer. I'm going to do a second example as well on the quotient rule, but there's a time limit on these videos of 15 minutes, so I'm going to stop this one there, and I'll do a separate video with a quotient rule example done, because it can be a bit more complicated with a quotient rule, because you're starting out with, having done the differentiation, you're starting out with something that is already part of a fraction, so that can get a little bit more complicated as well. So I'll do an example like that one. So have a look at that, please.